Welcome to the International. I'm Nirvana speaking. This is related to engineering service main video electrical engineering volume 1. Here the one problem is coming from double cage induction motor. What is the purpose of double cage induction motor? What is the purpose? The double cage induction motor, the outer cage has more resistance as compared to the inner cage, causes more impedance, as a result less current, less torque at the starting. Then in starting the motor is started mainly because the outer cage having more resistance. Running constant torque is produced by the inner cage. That is the main purpose, the advantage of the double cage induction motor. The problems are self-explanatory. Is simply how you have to calculate the impedance of outer cage in inner cage, then outer cage current, outer cage inner cage current, then outer cage power, inner power torque. Only one thing, starting slip of the induction motor is equal to 1. That is the only one difference. Question number 2. Here also the problem is related to transmission line parameters. Here you have to know what is the transmission line parameter, what are the line parameters you should know. Then you can do it a calculation. So what is the here gives me velocity of propagation, line wavelength and source impedance. The propagation constant is given by gamma is equal to alpha by JB. Alpha is equal to attenuation constant. Beta is equal to phase constant. Beta is equal to root over LC. Beta is equal to root over W into root over LC. W is equal to 2 pi 50. And what is the formula will come? Velocity of propagation is 1 by root over LC. And the line wavelength is equal to B by F. Source impedance root over L by C. And the source impedance losing is the I square value B I square by ZC. Source impedance is the root over L by C. Source impedance loading is the power transmitted when the line is terminated to a purely resistive load equal to source impedance. Source impedance loading is calculated VL sky by Z, or VL the line to line voltage at load, ZS is the source impedance of the line. This is the problem number 3 is related to here also the problem is it depends on the penalty factor, because in the penalty factor we take loss of the transmission line into consideration. In the penalty factor we take the loss of the transmission line into consideration. In penalty factor, the factor by which the incremental cost of power products of the plant must be multiplied to account for the transmission losses. So it is defined as the ratio of power generated by the plant to the actual power demand of the load being met after meeting the transmission loss. Here is the one formula is there. The system operated at economical dispatch means P1 P2 is equal to 80 megawatt. Here the formula is called alpha. Here the formula is that. So the formula is equal to df by L1 into df by dp1 is equal to df2 by dp2 is L2 and is equal to lambda. Here L2 is equal to 1 by dpl by dp2. Here is dpl dp2 given 0.2. So L2 is coming 1.25. That is after putting the formula, the lambda is coming 60. This 60 is equal to L1 df by dp1. We have to calculate L1. df by dp1 is already know 2p2 into 32. 2p into 32. p2 is equal to 80. After the calculation, L1 is coming 1.51. Then problem is question number 4. It is related to here only F is equal to QE and F is equal to mg. If you know mg is equal to Q, Q is equal to mg by Fe. Q mg by F is equal to mg and F is equal to QE. Q is equal to mg by E. So m is the G is there. So you can calculate easily. The Q is coming 4.7 to 10 to the minus 19. Here the Maxwell equations. The Maxwell equation for the static field, that is del D is equal to rho B, del B is equal to J, del call E is equal to 0 and call B is equal to 0. That is with this the present the company like it, subscribe, put the bell icon. Thank you.